In this video, we're going to look at sketching quadratic curves. A quadratic curve can be written in the form y is equal to ax squared plus bx plus c. These are called parabolas. So let's just have a quick sketch up and we will go ahead and draw sketches. When we talk about sketches, we don't have to have an accurate plot. We have the general shape of the curve and any points of intersection. So what we're going to look at now is when we have a positive quadratic. That is when a is going to be greater than 0. An example might be y is equal to x squared plus x minus 12. So the coefficient of the term in x squared is going to be greater than 0. If we do that, what we'll have is a parabola that opens upwards. So I'm just going to sketch this now and it will look, give or take, something like so. So we've got now a nice sweeping curve. It's not a load of connected lines, it's a nice sweeping curve. So that is what we have. We say that this is the minimum point. So the minimum, it's not quite accurate. If I wanted to make it look slightly more accurate, given the equation that I've just given, we would have something like so. So this is the minimum point. We would have now an axis of symmetry, and that would be now a line. So the minimum point's just here, an axis of symmetry. We would have a point of intersection with the y-axis, that's when x is 0, and up to 2 points where the curve meets the x-axis, and that's where y is equal to 0. So y is equal to 0 here, y is equal to 0 here, if it has real solutions. X is equal to 0 here. This is called now the axis of symmetry. So axis of symmetry. And then this is called, this point just here, this is called, in this particular case, the minimum. It's a vertex. It's symmetric about this line right here. And as stated, if a is greater than 0, it's going to open upwards. If a is less than 0, we have a negative quadratic, and that will open downwards. So we have something like so. Again, we might have up to 2 solutions where y is equal to 0. Y is equal to 0 here. We would have now a point on here where x is equal to 0. This point right here we would call again a vertex, but this is a maximum. So this is the largest value the function can give, and then we would have now the axis of symmetry. The axis of symmetry will give us an equation, and it will be x is equal to some value. So positive quadratic, negative quadratic. If we just look at a graphing calculator, this is a positive quadratic equation, and let's just put some values in. So for example, now this is going to be, and I'll make this, let's make this x's, I'll just put some nice numbers in, and then we're going to have that. This is the quadratic equation, y is equal to x squared, and I'll write it here, x squared minus 2x minus 8. So let's just write that up. So the one I've just drawn, y is equal to x squared minus 2x minus 8. We can see the points of intersection with the x-axis and the y-axis. We can see that it opens upwards. It's a positive parabola with 2 real solutions. If we look at another example, let's go ahead and draw this one. This has no real solutions for x as it doesn't cross the y-axis. We'll consider examples of that shortly, but that now is a positive quadratic with no real solutions. If I wanted to draw a negative quadratic, that's what we have. Negative quadratic, we've got 2 real solutions, we've got a point of intersection with the y-axis, and we've got a maximum point just here. When we have the quadratic in the form ax squared plus bx plus c is equal to 0, if a is equal to 0, we have a straight line. So our quadratic term must have some value on there. So what I'm going to do is just simply go ahead, take an equation and we're going to go ahead and sketch the graph of this and an example that we can factor. Y is equal to x squared minus x, and then we'll have minus 6. I'm going to draw this one. So let's consider the points that we're interested. We're interested in the x solutions, the y solutions. We want now the vertex, we want the axis of symmetry, and we want the shape. So let's consider each of these in turn. So if I want to solve for x, I set y equal to 0. We've seen that we could factor this in previous videos. That's going to factor to x minus 3 and x plus 2. That will give me that x is equal to 3, or we've got x is equal to negative 2. So straight away I can look at graphing this, and this is a sketch. It's not a plot. It's not getting little squares in your exercise book. It's simply putting them on. Negative 2, and we're going to have positive 3. So that's going to be positive 3 on here. Okay, now that's given us where x is equal to y is equal to 0 to solve for x. If we now look at where x is equal to 0, y is going to be 0 plus 0 minus 6. So that is going to give us the point down here, and let's go ahead and draw that. That's going to give us the point now 0, negative 6. So I'll put that just here. So that is 0, negative 6. So we've got negative 2 naught, we've got 3 naught, and we've got this point 0, negative 6. That's simply by setting x equal to 0. So we've done that, we've done that. We're now going to consider the vertex. This is a positive parabola. It will open upwards, and we will have now a minimum point down here. So I'm going to sketch this. Again, drawing on here is incredibly tough, especially as we're coming on quite a big, so round, do something like that, and then it'll come round, and we'll come up, and it'll look something a bit better than that, but that just gives us some idea. So that's what we've got. Let's just tidy this up down here. So you'll get more confident the more that you do, especially if they're on paper. They're slightly harder on here, but hopefully we'll get some representation. That looks a bit better. There we go. So that point is here, 0, negative 6. This is negative 2, 0, 3, 0. We've got two real solutions, as we've just found, and then the shape now opens up. Okay, now the vertex, well, that is going to be this minimum point here. When we've got this factored, all we need to do is simply find the distance between the two solutions and half it. The distance is 5, that's 2.5, so I'm simply going to subtract 2.5 from 3. So at this stage, I'm going to put this on, and that, let's just change the colour, let's make that a bit, let's go for that one, there we go, that looks a bit better. So what we can say then is that the axis of symmetry is now the point where x is equal to 1/2. That's the equation of the axis of symmetry. We've got now a minimum point just here. In completed square form, the minimum point is so much easier to see, and that's what we're going to do. So with our minimum point, we could find the coordinates by simply substituting in that x was equal to 1/2. So if I wanted to put it in here, I could put it in here. If I wanted to put it in here, it's entirely up to me. So the y coordinate is going to be 1/2 squared, which is going to be 1/4, minus 1/2, which is going to be 2/4. Then we're going to have minus the 6, which is going to be 24/4. So that's going to give me, what are we going to have? Minus 25/4. So this point right here is going to be 1/2, comma, and then we're going to have negative 25/4. So that's what we get. If I completed the square, then all I would have had is now y and was equal to x minus 1/2 all squared minus 1/4, and then we'd have minus 6, which is the 24/4. So this is going to give me x minus 1/2 all squared minus 25/4. If we go back to our graph transformations, this is a graph transformation to take us to the minimum point. what we've got here, and I'll just sketch this to the side, we've got, let's change that over to a solid line. If we start off with a graph of y is equal to x squared, all we need to do is carry out two transformations. If we look at the vector right here, we've got now the f of x minus a, and then we've got plus b. So this moves 1/2 to the right, and it moves down by the 25/4, and that's what happens. So what we do is move half, and then we move it down, and that gives us the minimum point. So in completed square form, we can really benefit from those graph transformations to take us down to the minimum point. So that's all we need to do. To sketch, we need x coordinates, y coordinates, a vertex, the axis of symmetry, and the shape. The minimum point coordinates were given by completing the square. Hopefully, if you've done graph transformations, that makes perfect sense. If you wanted to look at that as two transformations, f of x minus a, and then f of x, and then we would have plus a. So this moves to the right, and this one moves down in our particular case. So we'll do a few of these, and hopefully they will make some sense. So in question 10, we need to sketch a graph of y is equal to x squared plus 4x plus 1, showing any points of intersection with the coordinate axis and the coordinates of the minimum point. So it's telling us that we want the coordinates of a minimum point. We're going to have to complete the square. So with this one, what I'm going to do is complete the square. So in the last video, we saw that this can be written as y is equal to x plus 2 all squared minus 4 plus 1. So y is equal to x plus 2 all squared minus 3. So that is in completed square form. So if we just consider, all we're doing is moving 2 to the left and 3 down. The vector for the vertex from y is equal to x squared, or the origin, is just 2 to the left and 3 down. If I just do some down here, let's just have some completed squares. Let's say we've got y is equal to x minus 3/4 all squared plus 2/3. The vector we would move this is 3/4 and then 2/3. We would move now to the right by 3/4 and we'd move up by 2/3. So let's now consider that this is our minimum point. The coordinates of our minimum point are going to be negative. They're going to be on here -2, -3. Now, what I want is when y is equal to 0 and when x is equal to 0. So when x is equal to 0, y is going to be equal to 2 squared minus 3, which is 1. Or, of course, we can sub it in here. So that's going to give us now 1. And that's what we have. What we now need to consider is when y is equal to 0. In the last video, we looked at this. So when y is equal to 0, we will have 0 will be equal to x plus 2 all squared minus 3. So we need to solve this equation, adding 3 to both sides. We've got x plus 2 all squared. Taking a square root of both sides, plus or minus a square root of 3 is equal to x plus 2. Subtracting 2 from both sides, we've got -2 plus or minus the square root of 3 will be equal to x. So we've now got where it crosses the x-axis, we've got where it crosses the y-axis, and we've got the minimum point. So that's the advantage of completing the square. So what we're going to do is a rough sketch. Remember, we don't have to be Picasso here, it just gives some idea of what's going on. So the easiest one to put on now is the point just here, 0, 1. That's where it crosses the x-axis, the y-axis when x is 0. The next one we've got is -2 plus root 3. Now -2 plus root 3 is going to be about here. The square root of 3 is about 1.7. So this point here is going to be -2 plus the root 3, 0. Don't write that it's about -0.3. You've got to write it in exact form. The other one is going to be just here, and that's going to be the -2 minus the root 3, 0. We looked at those solutions in the last video. So at this stage, all I'm going to do is simply go ahead now and draw this. So what we've got is something that looks like so. So the parabola will come down, it's symmetric about its axis of symmetry, then it will come back through and it will do something like that. And I'll just put that bit a bit further up. Often it's easier just to label up afterwards. This minimum point here, we've already established that that has the coordinates -2, -3. So we can put this just here. This is -2, -3. That is the minimum point, or the vertex. X is equal to -2 is the axis of symmetry. So axis of symmetry. So that's what we've got. That's our sketch. We've got everything we need on there. We wouldn't be expected to draw the axis of symmetry. I'll put it on for completeness. What we need are the X solutions, the Y solutions, the minimum point, and the general shape. So let's go ahead and do another one. Right. Sketch a graph of y is equal to 2x squared plus 5x minus 4, showing any points of intersection with the coordinate axis and the coordinates of the minimum point. So I'm just going to go ahead and complete the square. So y is equal to 2x squared plus 5x minus 4. So taking the 2 out, we've seen this in the previous video, x squared plus 5 over 2x, then we have the -4. Y is equal to 2 lots of completing the square. We're going to have x plus 5 over 4. That's half the coefficient. We need to square the bracket and subtract away 25/16. Now if you're sitting thinking, what's going on here? Watch the video prior to this one. Multiplying back through, y is equal to 2, then we're going to have x plus 5 over 4 all squared minus 25 over 8. 2 multiplied by 1/16 is 1 over 8. Minus now, this is going to give me 32 over 8. So in completed square form, y is going to be 2 lots of x plus 5 over 4. All squared, what's that going to give me? Minus now, we've got minus 57 over 8. Okay, right. So what does this tell us? Well, this tells us now that the minimum is going to have the coordinates here of -5 over 4, and then we're going to have, sorry, this shouldn't be an equal, should it? My apologies, let's get rid of that. That is not an equals, that should just be minus the 57 over 4. Let's just take that back and there we go, let's just get rid of that. We need that one, that's what I want. Right, okay. So what we've got on here now is the minimum is going to be -5 over 4, comma, -57 over 8. So a much more challenging one. Okay, so that's the minimum. That's fine. What we're going to do is look at when x is 0. So when x is equal to 0, we've got y will be equal to -4. That's nice and straightforward. X is 0, y is -4 by simply substituting in. Okay. This is when it gets slightly harder. When y is equal to 0, we need to solve this right here. So 0 is going to be 2x plus 5 over 4, all squared, minus the 57, so 57 over 8. What I'm going to do is add the 57 over 8 to both sides and divide by 2. That's going to give me 57 over 16 is equal to x plus 5 over 4, all squared. So all I've done, added 57 over 8 to both sides and divided both sides by 2. So we can say plus or minus the square root of 57 over 16, which is plus or minus root 57 over 4, will be equal to x plus 5 over 4. Subtracting the 5 over 4, we've got -5 plus or minus a root of 57 all over 4 is equal to x. And that gives us what we need. If we think about this reasonably, root 57 is going to be somewhere between 7 and 8, not a massive mile off the middle of 7 and 8. So we need to draw a sketch. So this one, as you can see, is significantly more challenging in terms of finding values, but we've got enough information to do this. So let's go ahead and put the values on. So we've got this point right here. That's going to be 0, negative 4. So x is 0, y is negative 4. So what we've got here is the negative 5 plus about 7.5 over 4, which is going to put me somewhere just here. I'm going to write the exact value of negative 5 plus root 57 over 4, 0. And then if I think of this one over here, what we're going to end up with now, let's just put this somewhere, let's put this well over here. What we're going to have is now negative 5 minus that. So we'll have that somewhere. And this gap is going to be bigger this side. Again, not massively accurate. So what we've got then is this point is going to be negative 5 minus the root 57 all over 4, 0. So that's given us these points right here. If we just consider, we've got our minimum point here, which is negative 5 over 4, and then we've got now negative 57 over 8. So that is going to be somewhere down here. Again, not massively accurate, but that's going to be the negative 5 over 4, negative 57 over 8. So it's going to look, and again, this is not hugely accurate, but it'll just give us some idea. There's the minimum point. We'll come round. We'll turn back, we'll come through now the y-axis like so, and then come through, and it'll look, give or take, it will be a lot more symmetric than that, but we'll put that point just there, we'll put that point just there, and that's enough. You might think, well, that's not very good. Again, a bit more practice, a bit more time, and an easier surface to write on, and you've got roughly what you need. You might want to pull this slightly that way, but that's what we have. So if we actually look at this one, I'll graph this one, 2x squared plus 5x minus 4. So 2x squared, I've got this up on here. So 2x squared plus 5x, let's get a plot of it, minus 4. So minus 4, that's what we've got. So there we go. I'm not a million miles off in terms of what I've done, as we can see just here. There we go. So the general shape is there. We've got these points on here. We've got now 0, negative 4. We've got negative 5 over 4, negative 57 over 8, and we can probably, there we go, there's negative 5 over 4 and negative 57 over 8, and that gives us now the minimum. Just out of interest, if this was negative 2x squared and it would be the other way up, we'd have a maximum. So that's why we have a minimum, and that's what it looks like. That point right there is going to be the negative 3.137. That's a rounded solution, and that's the other one just there. So there we go. That's what we get. That's a rough sketch, and you can see it's very rough, but we've got all of the main points on. Again, if you wanted to draw the axis of symmetry, you could do. Right. Okay. Let's go ahead now and look at the next one. We need to sketch a graph of y is equal to 3 minus 5x minus x squared, showing any points of intersection with the coordinate axis and the coordinates of the maximum point. So this time we've got a negative quadratic, and we can tell it's negative because we've got now the negative x squared. So let's just rewrite this. So what we've got then is y is equal to negative x squared minus the 5x, and then we've got plus 3. So I'm going to complete the square. As we saw in the last video, we can only complete the square if a term in x squared, the coefficient, is positive 1. So taking that out, I'm going to take out the negative one. We'll have x squared plus 5x, and then we're going to have the 3. Completing the square inside the brackets, we're going to have x plus 5 over 2, all squared, that's half the coefficient, minus 25 over 4. And then I'm just going to put on the outside 3, which is going to be 12 over 4. Certainly don't need to, it'll just make my life slightly easier. Multiplying back through, we've got now negative the quantity x plus 5 over 2, all squared. This is going to give me plus the 25 over 4, plus the 12 over 4, which is going to be plus 37 over 4. So the negative and the negative make a positive, and then plus that. Okay, so what does this tell us? Then what we can see then is the coordinates of the maximum point. We've got this now, and we're moving 5 over 2 to the left, so it's going to be negative 5 over 2, and then we're moving 37 over 4 up. So that's the maximum point. Okay, when x is equal to 0, so when x is equal to 0, we can see that y is simply going to be equal to 3. If these two are 0, y is going to be 3. So that's going to cross the y coordinate, the y-axis, sorry, at 0, positive 3. When y is equal to 0, so when y is equal to 0, 0 will be equal to this right here, which is negative x plus 5 over 2 all squared plus 37 over 4. So just rearranging, we can add this x plus 5 over 2 all squared to both sides. So x plus 5 over 2 all squared is equal to 37 over 4. Taking the square root of both sides, x plus 5 over 2 is equal to plus or minus the root of 37 over 37 is a prime number, so that's going to be 37 over 2. So x is equal to negative 5 plus or minus root 37 over 2. So that's now given us our x coordinates. Let's just go ahead and draw a sketch. Remember, this is opening downwards. So we've got now this point, and again, that point is going to be 0, 3. That's where it crosses the y-axis. We've got negative 5 plus the root of 37 over 2. Now, the root of 37 is going to be just over 6. So negative 5 plus 6 over 2 is going to be somewhere here. Not massively in that direction. So that's going to be the negative 5 plus the square root of 37 over 2, 0. The other one is going to be somewhere way, not massively, but let's just move that and move that. It's going to be a bit, let's make this look a bit more realistic. So that's going to be, let's put that there, that's going to be the negative 5 minus the root of 37 over 2, 0. And then we're going to have now this maximum point, and the maximum point, now if you think about 37 over 4, it's just over 9, so it's going to be somewhere up here, and then it'll, look, give or take, let's go just here. So this is going to be the negative 5 over 2, that's what we've got here, negative 5 over 2, and then comma 37 over 4, and that's our maximum point. So all we need to do now is draw the parabola. It will open up, and again, you might want to draw the parabola before you put the values on, because you can determine the shape of the parabola a lot better if you're not bounded by these values. But that's what it's going to look like, give or take. This point here is the maximum. So max, axis of symmetry, x is equal to negative 5 over 2. We've got the general shape, and that's what we've got. So there we go, nice and straightforward, nice and logical, takes a little while to get used to, but that is sketching a quadratic curve, generally speaking, from completed square form.